before.
Is this harder than the last time?
Yes.
What?
Okay, this test is just testing you on whether you can compute derivatives and simplify it for the most part. So let's go. We're gonna record everything. We're gonna record everything. So we're just gonna go one by one and have it on video.
Wait, make sure.
Now make sure. Now, number one, I have A through. Sit down.
Can I have a piece of paper, please?
No.
Can I ask someone for a piece of paper?
Yes.
Someone give me a piece of paper.
You have A through G over here, but on the test there's only A through E, I believe.
Yes.
That's a significant part of the test. So you need to make sure that you get the derivative part correct, because it's probably gonna be 5 points each. And if you get the correct derivative, I'll give you 2 or 3, and then the simplifying will be the rest. But if you don't, these fatal errors are gonna add up, quickly. And if you don't use the chain rule, like if you forget to multiply by derivative of box, that's a fatal error. So you gotta be careful. Okay, first step, derivative. Just make sure we get it. Watase, go. Oh, just do the derivative. Look, you have a product here. Product rule, go.
So x prime. Oh, derivative of the first.
X prime.
Oh,
The derivative of x is 1.
It's 1. E of the second alone, so 10 equals 2x plus x and the inverse of 10. 1 over 1 plus 4x minus.
Oh.
Wait, it wasn't doing
Yeah, I know. That's why I let. Okay, right there. That would be a fatal error. -5. The derivative of tan inverse box is 1 over 1 plus box squared times the derivative of box. That would be a -5 there. Okay, continue. Redeem yourself.
minus.
Throw the 1/4 on the side, and then
Inverse 1 over 1 plus 4 squared.
the derivative of box. Okay. You know what? If we keep going at this rate, we're not going to even finish the video. I'm just going to do it. Okay, did everybody get this? And the reason why you're not coming out with the correct answer is probably you didn't multiply by derivative of box, but that doesn't matter because that's going to be a fatal error. You guys can finish this, right?
Yeah.
Okay, down's easy. The algebra is not much. Okay, B, we got y equal -1/3. Even this one, the algebra is not much. Unless you do dumb things like don't distribute the minus sign. Like if you do sloppy math. Okay, derivative. Now, when you have a constant like this, do you want to throw it on the side like an unwanted pet, or do you want to group it with the x squared like that? I already told you this.
Group it.
Yeah, you group it, because if you have to distribute it in the next step, that's just more writing. If you just group it with one of the terms, it's a lot faster. And when you have a minus sign like this, for those of you who've been keeping up, you probably know, you should write that as a plus, a negative like that, yeah? Whatever. Okay, here we go. First step. Who's got this one? Takada, go.
I'm still copying the problem.
I don't care, just look at this. Just tell me what the difference.
-1/3 x. Shut up.
What did you tell me?
No, you try it. -1/3 x squared
So you guys always gotta do it differently, huh? Okay, go.
minus -3x. Is that wrong?
No. What is the derivative of e to the box?
E to the box.
Takada.
Oh, sorry, I got it. E -3x power times -3x.
No. What is the derivative of the box?
Oh, just 1 negative.
What?
-3x.
People, if we don't have the derivatives memorized now, if you memorize the derivative wrong, what is that? Fatal error. Okay, so what did Takada do? He did derivative of the second, leave the first one alone. Now derivative of the first, Takada.
negative 2/3 x.
The second one alone, correct? Okay, now we have another product over here. Okay, redeem yourself, Takada, go.
Oh, negative 2/9 times.
Oh, now we're doing it the correct way.
Am I right?
Yeah,
Oh,
that's a good one. There's no, you're
Can I
correct.
just put the negative in 2, 9? Or
Yeah, that's what I did.
on the
Because it's
side?
better, if you do that, then you don't have to worry about, like a lot of people, they don't put the parentheses around it and then they forget to distribute the minus sign and then,
So it's better to do it that way.
yeah, it's a lot better, then you don't have to worry.
Okay.
Okay, continue, Takada, go.
leave the other one the same. So,
Okay, I will.
negative 2/9x, and then e to the negative 3x power times negative 3.
Okay. See how you learned the second time? Among,
Yeah.
put your iPad away.
Do you want me to write it down on the hard copy and then write it down again on
You
different
lost your
paper?
privileges with the iPad, I already told you already. Okay, finally, last one. This is a constant. You throw the constant, the constant on the side like an unwanted pet, and then you multiply it by the derivative of that.
Keep that in times negative 3.
Okay, so e to the box times the derivative of box. And if you do your algebra correct, I bet you, how many terms are there? 1, 2, 3, 4, 5. I bet you 4 out of the 5 cancel out.
Oh,
Since I wrote that problem, yeah.
Wait, so like a problem of like this caliber is gonna be on our test?
Yes, that's why I put it here.
Oh.
But no, all you have to do is product rule, that's all you gotta do, product rule, and just remember to multiply by derivative of the box.
There's so many of them.
Well, okay, why don't I just not give you practice tests anymore and just shock you on the test? Let's do that, that sounds like fun. Okay, 1/3, and see, there's a couple people coming in for help, but you guys are not doing what I told you. When you have a trig function to a power, write it like this, so you know that you have box cubed. Minus tan x plus x. Okay, derivative among.
Tan x to the, or tan squared x, sorry.
Okay, we can do that.
Yeah. Times secant squared x times 1
Okay.
minus secant squared x plus 1.
Okay, now that one is pretty easy, but now you gotta simplify. Do you need me to simplify?
Yes, please.
Okay, now look. Obviously, there's, well, 3 things you can do. You can change everything to tangents, you can change everything to secants, or you can just change everything to sine and cosine. But you gotta simplify it somehow. So what would you do on the test?
Wait, can you not just take out secant squared?
Yeah, but then this one doesn't have in it. You know what I mean? Like you can't take it out from all of the terms.
That's my bad.
So what do you wanna do? You wanna change both of these to tangent squared plus 1? Or you wanna change that one to secant squared minus 1?
Yeah.
Yeah.
Or would some of you just stop and go on to the next problem? Maybe that should be a strategy for some of you. After you take the derivative, I think I told you guys this, yeah? Just go to the next problem, and if you have time, then you come back and simplify, because some of you have simplifying problems,
How
right?
much is it minus? How many points?
It's gonna be around half
Oh,
for
really?
simplifying, yeah.
Minus half?
Wait, did
or-
you get the tangent squared, secant squared x from like each
Yeah, because what's the derivative of box cube?
Oh.
You put the 3 in the front, that's what cancels the 1/3, right? So it's gonna be 3 box squared, that's what this is, times the derivative of box, which is that. So if you forget to multiply by this derivative of box, it's all over, you got minus 5 or 6, whatever it's worth. Okay, tell me what you guys are gonna do.
How are
You either change this to secant squared
by
minus 1, or change these to tangent squared plus 1. And if you don't even know those identities, then you just lost 100 points right there.
Secant squared minus 1.
Okay, change this to secant squared minus 1. Okay, so multiply it all out. What do we have? Secant to the 4th x minus secant squared x minus secant squared x plus 1. And that's secant to the 4th x minus 2 secant squared x plus 1. And isn't that factorable? Isn't that secant squared x minus 1 quantity squared? That's a perfect square. And A, you somebody,
And
that's tangent squared. So what is tangent squared squared? tangent to the fourth x, and that's your answer. Ooh. Oh, so we gotta know trig identity. You gotta know trig identities through this whole course, people.
Yikes.
Why do you think we spent over 3 weeks in the beginning
Wait.
reviewing?
Hey, we finished C.
Okay, moving on, D. Okay, now, if you had problems with D, that's because I think it was the algebra. Y equals, I'm gonna throw the 1/2 in the front like this. And I'm gonna rewrite 4 plus x squared, I mean the square root as to the half. Did you guys do that?
Yes.
Okay, this one I'm not, we'll just see what you do with it. Okay, just make sure you get the first step, okay? So, derivative. So, group these two together, you gotta do product rule, okay? So, derivative of the first, leave the second one alone. Plus, leave the first one alone, derivative of the second. Now, what do I see? I see box to the half. How do you take the derivative of box to the half? 1/2 box to the negative half times the derivative of box. If you don't put that 2x there, boom, it's all over. But that's what this test is. It's the chain rule. That's pretty much what this test is. Plus 2, that's a constant, throw it on the side. Now, what's the derivative of natural log box?
1 over box.
1 over box times the derivative of that box. Now, what's in the box? That. So what's the derivative of x? 1 plus, and you probably should think of that as 4 plus x squared to the half power, right?
Yeah.
So maybe, I don't know.
Wait, why didn't you leave it though?
I don't know, because I thought you guys could do it. But I guess not. There comes a time we're gonna have to do that now. 1/2 box to the negative half times the derivative of that box. Okay, so to get any points at all, you gotta write that down. Now, do you need me to simplify this?
Yes.
Oh gosh. All right. It comes out really nice, you know. That's why I made this. See, there's no textbook I've ever seen that has these problems.
You should just
It's
keep
me.
on
I have a
thinking
whole
about
like, I have like 5 pages of these.
You're the best.
Thank you. Okay, so what do we got here? We got, now, if you have hard time with fractional exponents, and I know you do, change it back into radical form. So like this, isn't that radical 4 plus x squared over 2? Yeah. Plus, now can I cancel that 2 with that 2? So what do you have? I have x squared on the top, there's a 2 on the bottom, and negative half power means 1 over. Like that. Because you guys have, or do you want me to change that to radical?
Yeah.
Okay. Whatever is gonna help you. Whatever is
keep
gonna
it all
help
the
you,
same.
because this is simply algebra, people. Plus 2 times, okay, you better do this. 2 times, now this denominator is x plus root 4 plus x squared. Now, times, now what the heck is this, Mr. Park? Well, that's 1 plus, these 2's cancel out, and you get x over radical 4 plus x squared. Woo! Oh, I don't want to write everything again, but you know what? Okay, let's just not skip a step, but let's squeeze it in here. How do you add fractions? What do you do?
He's coming.
You make a least common denominator. So, what is the least common denominator? Root 4 plus x squared. What goes on the top?
3.
Root 4 plus x squared plus x. So there you go. Let's put that there. Root 4 plus x squared plus x. Okay, there. Do you notice anything? Do you guys notice anything?
There's a lot of root.
No, look! This cancels that. That's beautiful. Okay, so this is what we got right now. How are we going to even make it through this worksheet? All I can say is you're in trouble.
These problems, like, they take so long. Just for like,
And I
Yeah,
always
that's
mess
why
up.
you gotta sit down and struggle with these. That's
It
the
just
only
takes
way you
one
can get better.
Yeah.
it just takes one mistake.
My paper's like falling apart today.
Okay, look at these 3 fractions. What is the least common denominator of these 3 fractions?
2 root 4 plus
2 root 4 plus x squared. Okay, what goes on the top? Well, this one you gotta multiply top and bottom by root 4 plus x squared, so you're gonna get 4 plus x squared. This one is already, so just leave it. And then this one you need to multiply top and bottom by 2. So you got 4. So what do you got? You got 2x squared plus 8 all over 2 root 4 plus x squared. I factor out the 2, x squared plus 4, all over 2 root 4 plus x squared. The 2's cancel out. Final answer? We talked about this in
Square root of
class.
x squared
If you
plus
have
4.
a over a to the half, subtract exponents and you get
Square root of x.
square root of 4 plus x squared. There you go.
Why would you ever put it in the square root?
You can do whatever you want. I'm just doing what comes to mind here. Because somebody said change it back to radicals.
Well, you had the first one in radicals, that's why.
Whatever. It's just, some of you still don't get it. I don't care whether you write the answer like this or you write the answer like that. They're exactly the same answer. It doesn't matter. Do whichever one you want. I'll accept it. Okay, we better move on. Oh gosh, we're not even out of number 1.
Can we just skip,
last.
can we just skip the logarithmic differentiation? Which one's that?
Okay, yeah, we're getting there. We're not even close to there yet. Okay, you know what? I'm just gonna have to breeze through these and you watch the video on your own. Well, if I knew this is gonna be this bad, I would have come 5 o'clock this morning and film it.
You didn't think it was gonna be this bad?
No, I didn't. Because normally, usually like at least 3/4 of the class actually does it. This class is less than half. Okay, so, here, that's okay. It's okay. Okay, I'm gonna group the constant with this thing over here. So here we go. Derivative of the first. Throw the 3/13 on the side like an unwanted pet. Right? The derivative of e to the box is e to the box times the derivative of box. You don't multiply by that too, it's all over but the grind. Leave the second one alone. Plus, now you leave the first one alone. The derivative of the second. Now what do I see here? I see sine box. What's the derivative of sine box? Cosine box times the derivative of box. See how every single problem you gotta multiply by derivative of box. Plus, now I see another product, use product rule again. Derivative of the first, so leave the 2/13 on the side like an unwanted pet. What's the derivative of e to the box? E to the box times the derivative of box. Leave the second one alone. Plus, now you leave the first one alone. Times the derivative of the second. Now what do I see here? Cosine box. What's the derivative of cosine box? Negative sine box times the derivative of box. Okay, that one simplifies very nicely, so I'm not going to do that. I'll come to the Okay, what's the next one? What do we got? F. Okay, now look at the 2 on the bottom. You want to just, what do you want to do with that 2? You want to put it in the front like a 1/2? Is that what are you guys going to do with this? Okay, don't answer me. We'll just find out then. I'm going to throw it up in the front like that. So let's throw the constant on the side like an unwanted pet. Okay, now what do I have here? I see a product. You got to use the product rule. Derivative of the first, 1. Leave the second one alone. Plus the first times the derivative of the second. Now what do I see here? I see sine box. The derivative of sine box is cosine box times the derivative of box. See, that's good because the x's cancel out. Minus, now, you guys need to put parentheses here because when you do the product rule, you got to do the product rule first and then subtract. So that minus sign got to be distributed. So here we go. Derivative of the first, leave the second one alone. Plus, leave the first one alone, times the derivative of the second one. Now what do I see? I see cosine box. So it's going to be negative sine box times the derivative of box. And if you distribute that minus sign, good things happen, right? Because like I said, this x and that 1 over x cancels out. So that one will come out very nice as well.
Will you
Yeah.
ever give us one that doesn't come out nicely?
I gotta keep you honest, right? Can't make them all come out nice.
Why not?
Or can I? G. Y equal x squared secant inverse x minus, and do you want me to change that to x squared minus 1 to the half?
Yes, please.
Okay, I will. Okay, product. I'm going to use the product rule. Now, there's a restriction on this problem that says x is greater than 1. Why did I put the restriction there again?
Absolute.
For the absolute value. So, derivative of the first, leave the second one alone. Now you leave the first one alone. Now, what's the derivative of secant inverse x? 1 over the absolute value of x times the square root of x squared minus 1. How come I didn't need to put absolute value? Because of the restriction. Minus box to the half. 1/2 box to the negative half times the derivative of box. Now, if you do your simplification right, this term cancels that term, so that's just your answer there. So, probably for you guys, the hardest problem was D then, yeah? Oh. Okay, number 2. Hey, this is just like the last quiz we took. Except it was x squared plus y squared, now it's x cubed. I told you. So if I'm giving you x cubed plus y cubed on the practice test, what is it gonna be on the real test?
X
gonna
cubed
4?
minus y cubed.
Equal 9. Compute the second derivative at the point 1, 2. Okay, so let's just do what we did last time. Implicit differentiation. 3x squared. Now remember, when you do implicit differentiation, when you take the derivative of x, you get 1. But when you take the derivative of y, you get y prime or dy dx. So this is like box cubed. 3 box squared times the derivative of box, which is 1. Box cubed. 3 box squared times the derivative of box, which is y prime. So if you don't put that y prime, it's a fatal error. That's what it is. And the derivative of 9 is 0. So 3y squared y prime is equal to negative 3x squared. Y prime is equal to negative 3x squared over 3y squared. And just like the quiz, the 3's cancel out. Now, you don't have to cancel it out, but it's a lot easier if you do. And what do you want to do with this minus sign? Leave it on the top? You guys, I remember, you guys wanted to put it in the middle, yeah? Okay, so now we do second derivative. So take the derivative of both sides again. This minus stays in the middle, and then that's a quotient. You got to use the quotient rule. So low, d high, minus high, d low, 2y, y prime, all over denominator squared we go. Don't forget that y prime. Now what am I going to do with this y prime? Yeah, you have to take y prime, which is this, and plug it in over there. So you're going to get negative 2xy squared minus 2x squared y times y prime, which is negative x squared over y squared, all over y to the 4th. I think you guys can take it from there. Now, if you wanted to, you don't even have to simplify this anymore. You can just plug in 1 for x and 2 for y right now. But who knows, on the test, it might not give you a point. You might just have to compute the second derivative. Okay, I'm going to leave it up to you to simplify. We already spent too much time just learning algebra 1, relearning algebra 1. You guys got to practice. You guys got to deal with the algebra. Okay, number 3. Write the equation of the tangent line for this graph, arc secant x over 2.
Is that just secant?
That's the same thing as secant inverse, right? There's 2 ways of writing it. At x equal negative 4. Now remember, to write an equation of a tangent line, you need a point and you need a slope. Now, if the x coordinate is negative 4, how do you find the y coordinate? You plug it in. If I plug in negative 4, what do you got, Okazaki?
Negative, secant inverse of negative. Oh, sorry.
Secant inverse of? Plug in negative 4.
Negative half. Negative 2, sorry.
Which is? That's a number we know. Secant of what angle is negative 2?
Pi over 3.
No. Gotta be in the range, that's why.
Oh.
Range?
Pi over 4.
From negative,
2 pi over 3.
2 pi over 3. Okay, if you don't get that, you just gotta take the minus 2 or 3, whatever it is. Okay, now how do I compute the slope? You gotta take the derivative. The derivative of secant inverse box is 1 over absolute value of box times the square root of box squared minus 1 times the derivative of box, which is 1/2. Now, if you forget this 1/2, if this problem is worth 5 points, that's at least a minus 4. At least minus 4. Because maybe I might give you 1 point for that y coordinate there. Okay, so how do I compute the slope when x is -4? You plug in -4 into this. I'm not gonna do it for you, you guys do it. Plug in -4, and whatever you get is that, and then just do point slope form. Y minus 2 pi over 3 is equal to whatever the slope comes out to times x plus 4. We've been writing tangent lines for like the last 2 months already. Okay, next, number 4. Oh, I just wrote the test. This is definitely on there. In fact, almost all of these are on there. Except, I think I didn't give you a problem like 1D because I didn't think you guys could handle. Unless you want me to challenge you.
No.
Okay, now, when is the first derivative greater than 0? When is the second derivative greater than 0? So what are you thinking when you see like inequality, like greater than or less? You gotta make a number line. So take the derivative and make a number line. Now, I see a product here, you gotta use product rule. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. So e to the box is e to the box times the derivative of box. So if you don't multiply by that derivative of box, it's all over but the crime already. Okay, what can be factored out? E to the -x, what's left? 1 minus x. Now you make a number line for it. What goes on this number line? What makes this 0? 1. What makes this 0? We talked about this several times. Nothing. This e to the something is always positive, no matter what. You can plug in any number you want, it's going to be positive. So basically, you're just making a number line for that. So plug in a number bigger than 1. 2. 1 minus 2 is negative. Negative times positive. So the number line looks like that. I think you can answer the question now. Greater than 0 means the plus now. Now we got to do second derivative. Now look right here. I have a product. You got to use the product rule. Derivative of the first, so e to the box. So it's e to the box times the derivative of the box. Now, at this point already, you guys should be able to handle, like, just put the negative in the front, right? I don't have to, well, derivative of the first, leave the second one alone. Leave the first one alone, times the derivative of the second one. What's the derivative of 1 minus x? -1. So, or should we just put the minus right there? I don't care, just take care of the signs. What can be factored out? Now, do you want to factor out an e to the -x or a negative e to the -x? It's up to you. Wait, negative e to the -x, what's left then? 1 minus x, and then plus 1. So you got negative e to the -x, 2 minus x. So when you make your number line, 2 goes on the number line. What makes that 0? Nothing. That's always positive. So think of a number bigger than 2, like 3. If you plug in 3, you get, that's negative, that's positive, but that's negative. So what? Positive and then minus, and then you can answer the question now. So yes, you're going to have to make number lines. In fact, next chapter, that's why this chapter, I keep telling you guys, this chapter we're learning how to find derivatives. Next chapter, we're going to use derivatives to solve problems. And we're going to do this every single problem.
Can we just leave the number line? We don't have to like...
No, you got to answer the question. So the question says greater than 0. Greater than 0 means the plus, so your answer will be 2 to infinity. You can't, the number line is not an answer. Caught.
Is there a negative sign in front of that?
Yeah, the negative sign right there. Yeah, we accounted for it because if you plug in 3, 2 minus 3 is negative, right? So negative times positive times negative, right? It will be positive, yeah. Yeah, don't just throw in a negative sign away.
Wait, so it doesn't include the number?
No, because this point makes it 0. This
Oh,
we want greater
I
than
see.
0. Okay, number 5. Okay, this is like the last quiz question. Okay, now, on this worksheet, we got horizontal and vertical. On the test, it's just going to be one of them. Remember on the quiz what it was?
Horizontal.
No, it was vertical, the quiz.
Oh.
So what do you think is going to be on the test?
Horizontal.
You can guess whatever you want.
Whoa.
Just make sure you get it right. Okay, so since it's difficult or impossible to solve for y, we're going to do implicit differentiation. So I'm just going to do this fast. 4x plus, make sure you use the product rule here, 1 times y plus x times y prime plus 2y y prime equals 0. Don't forget now, you got to think of that as bots. But again, the derivative of x is 1, the derivative of y is y prime. Okay, and then I'm just gonna save time here. Take these two terms and move it to the other side. Negative 4x minus y. If you factor out the y prime, you're gonna get x plus 2y. That's the derivative. Now, for part A, when the tangent lines are horizontal, what's the slope of a horizontal line? 0. What makes this derivative 0? When the numerator is 0. So what you do is you set the numerator equal to 0. For part B, it says vertical. What's the slope of a vertical line? Undefined. So you make the denominator equal to 0. And then I'm not going to do this for you. You guys know what to do. So whichever one you have to do, like this one. Solve for one variable. It doesn't matter which one. So in this one, y equals negative 4x. What do I do with this? You take it and plug it back into the original function and solve. Or do you want me to do it for fun? Huh? Number 6. There's problems on there as well. Hey, Mr. Park, every test so far we had a problem like this. That's right, because it's going to be on the AP exam. Okay, find the values of a and b so that this function is continuous and differentiable. Well, actually, I don't even have to say continuous, because differentiable means it's already continuous. But I just put that there, and the AP exam, they put that there just so that you can do it. Now, if a function's going to be continuous at x equal 1, what do? We did this the last 2 tests. Yeah, if you plug in 1 here and you plug in 1 there, you got to get the same number, otherwise they're not going to even meet. So plug in 1 for x here, what do you get? A plus b equal, plug in 1 for x here, what is sine of pi? 0. Okay, I'll give you 1 point for that. Okay, now, in order for the function to be differentiable, it has to be smooth when x is 1. Now, how can you guarantee the graph is going to be smooth? In other words, no sharp points. The left-hand slope and the right-hand slope have to be equal. And how do you figure out slope? Derivative. So what you gotta do is you gotta take the derivative of this thing. Okay, what's the derivative of that? That's easy. 2ax plus b. How do you take the derivative of sine box? Cosine box times the derivative of box. So if you don't multiply by the derivative of box, maybe you get 1 point. Maybe. Okay, so the derivative tells you the slope. So if we want the two slopes to be equal, if I plug in 1 for x here and 1 for x there, you have to get the same number because this represents the slope. So plug in 1 for x here, 2a plus b. That is the left-hand slope. Plug in 1 for x here. What is cosine of pi? No. Negative 1 times the negative pi. That's the right-hand slope. They have to be equal in order for the graph to be smooth. So all you have to do now is just solve these two equations, and look, if you just subtract them, you solve for a area, yeah? So you guys can do that. Number 7. Okay, here's the one. Somebody talked about this. Mr. Park, how do we know when we're supposed to use logarithmic differentiation? Well, whenever you have something to the something power, if this is not a constant and that is not a constant, then you have to do logarithmic differentiation. Like if one of these was a number, then we have other rules for it, but they're not. So this is the one you have to natural log both sides. Now, why do we natural log both sides? What purpose does that do? Yeah, you can move the power in the front. That's everything right there. And then once you do that, you do implicit differentiation. So here we go. Natural log box. The derivative is 1 over box times the derivative of box. Over here, I see a product. You gotta use the product rule. Derivative of the first, leave the second one alone. Plus, leave the first one alone, times the derivative of the second. Now, what do I see here? I see natural log box. What's the derivative of natural log box? 1 over box times the derivative of that box. What's the derivative of arctan x, which is the same thing as tan inverse x? 1 over 1 plus x squared. And then, how do you solve for y prime? How do I get rid of this 1 over y here? just multiply both sides by y. This is a really easy problem. Hopefully everybody can get this one on the test. Okay. Oh! Actually, there's one more step because it says find the derivative when x is 1. So if you multiply both sides by y, then you're going to have a y here. Yeah? And then it says when x is 1. So what you have to do is you actually have to plug in 1 for x. So that's no problem because what is arctan of 1? Tangent of what angle is 1? Pi over 4. That's pi over 1 over pi over 4. 1. 1 plus 1 squared is 2. But what do I do with this y, Mr. Park? Well, you go back to the original. This is y. So if you plug in 1 here, arctangent of 1 is pi over 4. Pi over 4 to the 1 power is pi over 4. Yeah, so you gotta plug in numbers. Okay, number 8. Hey, now we're making leeway. F of x, not really, is natural log x squared plus 1. Oh my goodness! When is the second derivative greater than 0? So what you gotta do is take the second derivative and make a number line. There's gonna be a lot of algebra here. Okay, what's the derivative of natural log box?
1 over box.
1 over box times the derivative of box. Do not forget to multiply by derivative of box. Now we gotta do second derivative. Well, why would I make you make a number line for that? That's just too easy, right? So we do second derivative. I see a quotient, I'm gonna use the quotient rule. Low d high minus high d low all over denominator squared we go. Can you guys take it from there? Or do I need to? Okay, you gotta factor this thing, people. Okay, look, multiply. What are you gonna do in the test? Like, personally, I would factor out a 2 right now, but I don't know what you guys think. Just multiply out everything. 2x squared plus 2 minus 4x squared. So what does that come out to? 2 minus 2x squared all over x squared plus 1 squared. Factor out the 2. See? You're going to have to do it sooner or later. And is that completely factored? No. 1 plus x, 1 minus x, all over x squared plus 1 squared. Now you make the number line. What goes on this number line? What makes the top 0? What makes these the top 0? Negative 1 and 1. What makes the bottom 0? Nothing. In fact, the denominator is always positive. How come? Why is the denominator positive? Yeah, because you have something squared. When you square something, it's never going to be negative, right? So basically, you just got to make a number line for that. Come on, you guys can plug in numbers. You guys got to do something. Number 9. Okay, this is the one from the book. I told you it's on the test. I told you it's going to be on the practice test. And we're just going to see if you guys can do it. This is on the AP exam for the last 10 years, and it's not going to change. It's going to be there. Okay, now remember, if you have a function and its inverse, g is the inverse of function f. What is the relationship between the slopes again? Here, I'll draw the same picture I drew for you. If you have a function and its inverse, and you have a point here, let's call it a comma b. What is the corresponding point on the inverse? B comma A. Is there a relationship between that slope and that slope? Yeah, what is it? They're reciprocals of each other. So if this one comes out to 2/3, then that one's going to be 3/2. Just pick the reciprocal. So if you just do what I showed you last time, it's easy. Now what does the problem say? Compute g prime of 2. That means on the graph of g, which is the inverse, we need to compute the slope when the x-coordinate is 2. That's our goal, okay? What is the slope when the x-coordinate is 2? Well, if this is the inverse, then on the original function, what? If the x-coordinate is 2 here, what's the y-coordinate here? 2, because you switch the x's and y's. Now, this is probably the hardest part. When the y-coordinate, here's the function. When the y-coordinate is 2, how do I figure out the x-coordinate? Just look at it. What do I plug in for x so that the y-coordinate comes out to 2? Now usually it's going to be something really easy. Yeah, 1. Because if you plug in 1, look, 1 cubed plus 1 is 2. It has to be something pretty obvious, otherwise it's hard to do properly. Okay, so that means, can I figure out what the slope is? Yeah, how do you figure out slope? I take the derivative. What's the derivative of this? Okay, so when x is 1, plug it into the derivative, what do you get? 4. So therefore, on the inverse, what is the slope? 1/4. So whatever number you get here, that one is going to be the reciprocal of it. Because
Would it
that's
be
the,
negative 1/4?
no, not negative reciprocal, just reciprocal. Look at this. Look, both of these are positive, yeah. That's because they're symmetric about the line y equal x. Not negative reciprocal. If you put the minus sign, I would have to take off like 2 or 3 points there. Okay, let's keep on going. Hey, this is the last problem, yeah! We made it!
It says then we just have to solve for y, that means.
Huh? See that again?
We have to solve.
No, this is the answer.
Oh.
Okay, what does g prime of 2 mean? That means, what is the slope of the graph of g when the x coordinate is 2? Right? That's what g prime means. It means plug in 2 into the derivative, but the derivative tells you the slope. Okay, and before we do number 10, I just want everybody, you guys better know this because I put it on the last quiz and some of you bombed on this one. But you know the point values are going to be double, yeah? If y is equal to f of g of x, what is the derivative? How do you take the derivative of f of g of x?
F prime of g of x.
Times g prime.
Yes. This is the chain rule, people. This is the chain rule. You have to know it. Oh, I just thought of a problem too. Okay, before we do this last problem. Okay, this problem's on the test. Okay, so there was a problem in the homework. In fact, somebody asked me about it. It was on homework when you were doing your homework. So here, if dy dt equals 3, dm dt equal 4, and dx dt equal 5, compute dy dx. I should have put that on the practice test, but I didn't.
Is it gonna be on the test now though?
Yes, it's a homework problem.
No, yeah, I know, but it's
But
not
don't. But you know what the crazy thing is? Nobody asked about it on the homework.
I
I was
did.
gonna ask about it today. Yeah.
Okay, well, good thing.
I did, Mr.
Okay, now remember,
What's on 4.4?
Leibniz's form of the derivative, dy dx. You can treat this just like regular fractions. Okay? So you just gotta figure out, how do I make this so that I can treat it like fractions and cancel out? So dy dt. Now, if I want to cancel out this dt, don't I need dt on the top? But then look at this. So what you do is just reciprocatize dt over dm. And then if you want to cancel out this dm, then you need dm on the top, dm dx.
Oh, you messed it
Oh,
up.
so I messed up. This is an m. Sorry. dx. You see? Because look, this cancels this. This cancels that. What's left? dy over dx. That's what this is. Just treat it like everyday fractions. Okay? So, what is dy dt? Look at this. 3. What is dt dm? Well, this is dm dt, so what is dt over dm?
1/4.
Yeah, it's 1/4. It's reciprocal. And then what is dm dx?
1/5.
Yeah, 1/5. So your final answer is going to be 3 over 20. You guys understand that? You can treat it like everyday fractions.
Was this on the homework?
Yeah, it was, but nobody asked that question. I think it
Except
was
on the
like-
homework, it didn't give us the derivative, it gave us the function, told us to find the derivative.
Yeah, I know, but it's the same thing. It's the
What
same
number?
principle.
Wait, but so is that the kind of problem that it's gonna be, or is it gonna be different?
No, I'm going to make it like this.
Oh, wow.
So we just have to know that you just
Yeah.
have to reciprocate.
Yeah, it's easy. This is AB, people.
So it's easier than the homework problem.
I am not trying to trick you in AB. Like in BC, I try to put things in it. AB, you just got to do what you did. But then that's the problem. You did.
Wait, what homework number was that?
50 something on the chain rule homework.
It's on
4.1,
the first one.
50 something.
Yeah.
There was a cosine theta in it or something.
Yeah, it's like S and T on the homework
Yeah.
instead of D. I mean instead of M.
Oh, now I know which one to check. Okay, now number 10. It says compute the second derivative at pi over 8. So what you need to do in this problem, compute the second derivative and plug in pi over 8. Now, before you can get the second derivative, you better make sure you get the first
You
derivative
got the
correct.
Q.
Now again, you got a trig function to a power. I'm begging you already. Do that so you don't make mistakes. Okay, I see box cubed. So now you know 3 box squared times the derivative of the box. Now what do I see in the box? I see tangent box. What's the derivative of tangent box? Secant squared box times the derivative of that box, which is 2. Now, we did have this problem on the last test, but the derivative of box is 1, yeah, but now it's not. So you gotta keep multiplying by the derivative of box. So what do we got here? We got 6 tangent 2x squared, and then this one, secant 2x squared. Last chapter though, we had to do product rule with 3 things, but we don't have to do that anymore because we know the chain rule now. So let's toss this 6 on the side like an unwanted pet. Now let's do the second derivative. Okay, I see something times something, I'm going to use the product rule. Derivative of the first. Now what do I see? I see box squared. 2 box to the first times the derivative of that box. Now, what's the box? Tangent box. The derivative of tangent box is secant squared box times the derivative of box. Now that's just the derivative of the first one. Now you gotta leave the second one alone. Plus, now you leave the first one alone, times the derivative of the second one. Now what do I see here? I see box squared. Easy. 2 box to the first, 2 box to the first, times the derivative of the box. What do I see in the box? Secant box. So the derivative of secant box is secant box tangent box times the derivative of that box. Boom! See, this whole test is chain rule, people. You gotta multiply. See, if you've been doing your homework religiously, multiplying by derivative of box is nothing. Okay, now here's probably another hard part for you. Now plug in pi over 8. Pi over 8? I don't know that, Mr. Burke. Yeah, well, what is 2 times pi over 8? Pi over 4, tangent of pi over 4 is 1. That's easy. What about secant? Well, 2 times pi over 8 is pi over 4. What is secant of pi over 4? Root 2. I think you guys can handle 1s and root 2s, yeah? But can you see what this problem is testing out? You got box within box within box. You got to take care of those things. Okay, the bell's going to ring in 5 minutes. Woo! Oh, so the people who are absent, if they don't watch the video, they might bump this probably.
I doubt it. It's pretty simple.
Yeah, but you got to know. You got to know stuff.
Will you play us Musica?